Hi everyone, Dan Gunner from Insane Forensics. Welcome back to Tech Talk Tuesday, where every week we try to give you something to help your threat hunting and security program. And today what we're going to dive into is industrial cybersecurity terms, OT, SCADA, and RTUs, oh my. So people throw around a lot of terms from the industrial cybersecurity sector. Some know what they are, some don't. And so today we'll define those terms. We'll talk about how they all fit with each other, because how some people use certain terms isn't exactly how they mean to in other ways it is. And so we'll talk about what those terms are, what they include, and how they relate. So starting from the top, what is operational technology? And today as we talk through these, we're going to talk through really two main sources, what NIST says about it, and then we're going to pull in ChatGPT, because in this case what's interesting with that is GPT was trained on a whole lot of material, right, out on the internet, other material. And so the definitions it gives is going to be like an amalgamation of, what it's learned through different sources. So when we talk about operational technology, right, we're talking about programming systems and devices that do something in the physical environment, right? They're directing some change, they're monitoring. This might be in control systems, it might be building management, it might be fire control, physical access control, right? So a whole range of things fall under this category of OT systems. What I like on the GPT definition is it goes a step further and says, hey, this is both, hardware and software dedicated to monitoring and controlling these, right? OT is the umbrella which other technologies like ICS, SCADA, DCS, DCN, which we'll talk about, all fall under. And OT represents really that whole spectrum of technology that's involved in physical things and controls of industrial and other environments, right? Doesn't necessarily just have to be industrial though, so point off on GPT on that, but kind of the crux of it is with OT, you have that physical sense as well as, it being controlled by the hardware and software that drives it. When we go a step farther down, we'll say, okay, what are industrial control systems, right? And on the NIST level, right now we're looking at systems used to control processes. This could be manufacturing, production, distribution. So it may include SCADA systems, which we'll talk about over geographic areas. As well as distributed control and smaller control systems, things like PLCs and others. Another NIST definition, right? This, it's interesting. They call out and say, hey, within ICS, you have SCADA, you have DCS, you have PLCs. Don't worry, we'll all define them in a second. And ICS really is that combination of all of the control components. Your electrical systems, your mechanical. Maybe it's moving water. Maybe it's moving heat through, right? Acting together to achieve an industrial objective, right? If you look at GPT-4, what's interesting here is, ICS are the direct implementers of control and automation within this framework. They're the systems that OT uses to monitor and control industrial processes. So again, you have OT that's a high level. You have ICS, which I liked at the end how it was like, hey, this is actually how OT carries out those core components. Now, a core question that we're going to have here is, if ICS and OT are different, what is OT but not ICS, right? One area, building management system and building automation systems, right? Technically, those are physical things in the physical world being controlled by computers, but they're not technically industrial control systems, right? Medical devices, same deal. Environmental monitoring, physical security systems, the fire systems in a lot of cases, right? Oftentimes those can be OT systems, but they're not necessarily, tied to industrial uses, tied to industrial control itself. Even PLCs are not just used in industrial control systems, right? You walk into a lot of hospitals, you walk into really any office building, like the building we're in here, PLCs are driving certain parts of the lighting, the HVAC, other areas which again are not industrial. And it's important when you think about this definition to remember there are 16 different critical infrastructure sectors, right? We're just looking kind of at, one given one here when we're looking at ICS systems and industrial. Moving on, so we talked about ICS. So a subsection of ICS is going to be SCADA, right? What are a supervisory control and data acquisition system? SCADA is a subsection of ICS systems. And what SCADA is, again, we talk about transmitting over an area. As NIST says, right, it's a generic name for computerized systems gathering and processing data over long distances, right? So distance really is a key part of here, right? SCADA systems solve some of those unique challenges, dealing with things like phone lines, microwaves, satellite, usually shared rather than dedicated, right? We go to another, the GPT definition, right? Designed and perform data acquisition and high-level process supervisory, dispersed access, again, where centralized data acquisition is as critical as control. So think of this, like, right, a lot of SCADA systems are maybe like, an oil field, right? Distributed gas or oil field, where you have a lot of systems out in the field bringing data back to a central systems making decisions, pushing it back out, right? So again, you have that big geographic component to it. GPT, something it threw out there also was that SCADA systems really, again, provide that ability to monitor and control process over huge areas. So think nationwide oil and gas pipelines. Think, well beyond the confines of a single utility. In contrast, DCS systems, really deal with oftentimes a smaller geographic area, often a centrally located single unit. This is often used in, if you look at GPT, used in very specific complex process industries, chemical, pharma, power generation, where that reliability matters, right? You build a DCS system, you put together this combination of hardware and software to really make sure that what you're doing is done very precisely, very reliably, with a lot of continuity. It's a subset of ICS, right? Because it's dealing with that very discrete, continuous, complex process, granular, real-time control, plant operations type deal again, right? Comparing it to SCADA, you're doing it again at a small kind of single geographic area, to where SCADA is dealing with just massive distributed deal with that. We'll dive into each of them now, right? So I mentioned earlier, programmable logic controller, NIST definition, right? Single system, generally user program memory. You have ladder logic on there that's doing that is giving the logic to the device to act on, to provide certain outputs based on the inputs it's getting, or to interface with the world, right? Again, you look at the GPT, right? It's basically an industrial digital computer, ruggedized, designed for putting out in the field. And they're really good at the single set of tasks that is under that ladder logic, right? Generally under real-time constraints. PLCs are those workhorses, right? So when you think about the building blocks that make up DCS and SCADA networks, PLCs are those individual computers that are the Lego blocks in there. Another one you'll hear in there is remote terminal units. So again, these are a special purpose SCADA designed to support both DCS and SCADA remote stations or field stations, often have network capabilities. Oftentimes some people will try to use PLCs to serve as RTUs, and oftentimes then that PLC might be referred to as an RTU in the field, even though technically it's a PLC, right? Some people will put RTU like we do it just in SCADA. You can see under the NIST definition, they actually have it under both, so there's an argument to draw it under both. But again, RTUs really are those remote eyes and hands of the SCADA system, right? Getting the data, pulling it back. And so RTU, you'll hear this a lot when you're dealing with industrial networks with a lot of different industrial environments. So it's a good definition to have as you go out there. Human machine interface, HMI. So I like NIST definition, a hardware or software that the operator interacts with the controller. So a controller itself you don't plug in a keyboard and monitor to a controller. Generally that controller connects back to an HMI, or the HMI connects to the controller. And so the human machine interface is how you actually interact with the controller or with the network itself, right? HMIs, again, providing data visualization, system monitoring, control, that type of deal. They allow operators really to see parts of the system if they're not just looking at alarms coming off of that. Engineering workstation, another key one. So there's no NIST definition on here, which is kind of interesting. But they're another key part of DCS and SCADA systems, right? So your HMI is oftentimes used for kind of that day-to-day monitoring and simple configuration side, to where your engineering workstations are often used for that logic writing, for writing that logic back out, for doing certain diagnostic and programming tasks, configuration change tasks. So when you hear about EWS, that's another core one that you'll see out there. And again, an EWS goes across both that kind of SCADA and DCS bounds. So again, what we wanted to provide today was just the series of basic terms, what they are, where they're used, different definitions between NIST and what GPT kind of ingested based on its knowledge set. But hopefully this helped you understand the kind of breadth of terms that are out there. Again, people will use these terms interchangeably, so you have to be somewhat flexible on who's using it, how they're using it, what they refer to, but it's also important to be mindful that these actually are defined out definitions. So technically there is kind of a community agreed upon consensus on that. So hopefully this was helpful. We hope to see you back next week. Thanks for tuning in.